Good evening, Algebra 2 class. What we're going to be doing in this video is a quick speed run on how to solve exponential and logarithmic equations. We'll go back through those general steps, and then we'll also look at a couple of examples of each, as well as how to check your answers on logarithmic equations. So here's our first example, and also the general steps for solving an exponential equation. Remember, when you're trying to solve these, the first thing you have to do before you can do any of the fancy new Algebra 2 stuff is just to get the exponential piece of the equation alone. So in this problem, that exponential piece of the equation is this 8 to the negative 5x minus 3 part. In order to get that alone, we have to get rid of first this minus 2 and also this 7. So the first thing we'll do is add 2 to both sides. We'll go with 7 times 8 to the negative 5x minus 3 is equal to 77.8. After that, I want to get rid of that 7, so to get rid of times 7, we'll divide both sides by 7. We'll have 8 to the negative 5x minus 3 is equal to 77.8 over 7. We'll leave this like a fraction for now to try to stay as exact as possible. Now, this is when we get, that's step 1 done. This is when we get to step 2, right? We want to take the log of both sides in order to get the unknown, right, x out of the exponent here, right? So we're going to take the log of both sides, log here, and also log here. We end up with log of 8 to the negative 5x minus 3 is equal to log of 77.8 over 7. Remember, the reason we're doing this is because we can now bring that exponent down in front. So we'll have negative 5x minus 3 times log of 8 is equal to log of 77.8 over 7. We're just trying to get x alone at this point. We've done step 2. Now we have to solve for unknown values, that's x. So the first thing we have to get rid of is this log 8 here. So to do that, we're going to divide both sides by log 8. We'll have negative 5x minus 3 is equal to log of 77.8 over 7 over log of 8. Now on the left side, we just have a kind of linear expression to get rid of, so we'll have to add 3 to both sides. So I have negative 5x is equal to log of 77.8 over 7 over log of 8 plus 3. And we are almost there. Hold on 1 second. Just add the page extender. The next thing I have to do is divide both sides by negative 5. So end up with x is equal to log of 77.8 over 7 over log of 8 plus 3, all divided by negative 5. Now this looks like a giant mess, and it kind of is, but this is really just one big number over here on the right side, right? We can plug this into our calculator, and we actually end up getting that x is about negative 0.8316. Now, if you wanted to make sure that you were correct here, you could take that value and plug it back into your original equation. But in these cases, we don't have to worry about not having solutions for now. Moving on to our second example, right? Same idea here. Our first step is to isolate the exponential. So in order to do that, we're going to have to first add 8 to both sides and then divide both sides by negative 4. So negative 4 times 10 to the 8x plus 3 is equal to, well, negative 57 plus 8 ends up giving us negative 49. We now divide both sides by negative 4, so 10 to the 8x plus 3 is equal to negative 49 divided by negative 4, which is just 49 over Now we have the exponential alone, right? We've isolated the exponential part of this. We have to take the log of both sides in order to get the exponent out, sorry, in order to get the variable out of the exponent. And so I'm going to do the log of both sides, log here, and log here. Technically also log here, but we don't really care about that anymore. We are going to end up with log of 10 to the 8x plus 3 is equal to log of 49 over 4. Now the reason we do this again to bring the variable out of the exponent. So 8x plus 3 times log of 10 is equal to log of 49 over 4. Now at this point you may recognize, if you're kind of getting the hang of what logs mean, that log of 10 here is actually just 1. And in that case, that makes it a little bit shorter. If you don't happen to recognize that, though, then you can still go along as if we don't know that that is equal to 1, right? Because you can divide both sides by log of 10. So I end up with 8x plus 3 is equal to log of 49 over 4 divided by log of 10. And now as you have, again, a linear expression on the left side, we have to isolate x. So first we'll subtract 3 from both sides. 8x is equal to log of 49 over 4 divided by log of 10 minus 3. Moving down, we have to get rid of that 8, so we'll divide both sides by 8. X is equal to log of 49 over 4 divided by log of 10 minus 3, all divided by 8. And again, if you put all that into your calculator, either kind of piece by piece or all at once, you end up with x is about negative 0.2390. And again, you could go back, plug that number into your original equation, and just to make sure that you didn't mess up any math anywhere, just to make sure it works. Moving on to solving logs. So these are logarithmic equations, which means that our variables are stuck inside of the logs instead of inside of the exponents. So remember, when we're solving these, our first step is to condense and sometimes also isolate the log. That means applying those properties we've been using in class. Second step is to exponentiate. We'll get there when we get there. Then again, solve for the unknown. And in these problems, it's even more important to check your answers, and we'll see why in a second. But first, as we go through this, the first thing we have to do is condense our logs. So when we have addition, right, remember this is our product property of logarithms. So when we have addition to two logs being added together and their bases match, we can turn that into multiplication inside of the log. So this becomes log base 3 of x times x plus 8 is equal to 2. Just simplifying a little bit, it becomes log base 3 of x squared plus 8x is equal to 2. So that's step 1 done. All right, we've condensed this as much as we can. Now we want to get on this exponentiating step. So when we exponentiate, what that means is we are raising both sides of this into the exponent, and the base that we're raising them to has to match with the base of our log that we're trying to cancel out. So I'm going to raise both sides into the exponent with a base of 3. Next, we're going to exponentiate with a base of 3. So it becomes 3 raised to the log base 3 of x squared plus 8x is equal to 3 to the second power. Now remember, the reason we do this is that log base 3, or 3 to the log base 3, ends up canceling out. So these go away. On the left side, that means we are just left with x squared plus 8x. On the right side, 3 to the second power is 9. From here, this is a quadratic equation to solve. We've solved a billion of these at the beginning of the year, so we subtract 9 from both sides. X squared plus 8x minus 9 equals 0. This factors out nicely into x plus 9 times x minus 1. And from there, we're going to get that x is equal to negative 9, or x is equal to 1. Now, this is, so we went through step 2, went through step 3. In logarithmic equations, even more so than exponentials, it's very important to check your answers because it's quite common that one of them will not work. So when I say check your answers, what I mean is take the answers you got and try to plug them into the original equation. So if we check this first one, x equals -9, right, we'll get log base 3 of -9 plus log base 3 of -9 plus 8 is equal to 2. Now the issue right away is that we can't do the log of a negative number, right? There is no exponent, there's no answer to this log, because there is no exponent, there will be 3 to that exponent, gives us a -9. So this automatically is impossible. This actually also ends up being log base 3 of -1, which also won't work. Right? We cannot do the log of a negative number. So -9 does not work. Let's test x equals 1. If we test that, we get log base 3 of 1 plus log base 3 of 1 plus 8. Well, both of these do give us answers, right? Log base 3 of 1 will work, and log base 3 of 9 will also work. And even more specifically, it does satisfy this equation. So -9, no good. 1, yes. Moving on to our last example here. Again, we're going to start out by condensing and or isolating our logs. So in this case, we're just going to be condensing. So it's going to be log base 3. This is the quotient property, right? So subtraction outside of logs, right? Log minus log can become division inside. So it becomes 8 over x plus 8 is equal to 1, right? Log base 3 of 8 over x plus 8 equals 1. We have successfully condensed and or isolated our log. Now we have to exponentiate. So again, we have a base of 3, which means we're going to be exponentiating with a base of 3. So 3 raised to the log base 3 of 8 over x plus 8 is equal to 3 to the first power. Log base 3 and 3 cancel out, leaving us with just 8 over x plus 8 is equal to 3 to the first is just 3. Now, this is what's called a rational equation because we have an exponent. We have our exponent in our denominator here, right? We have a rational expression, a fraction. So we have to first multiply both sides by x plus 8. Or some of you are more comfortable thinking about it this way, you would think about it as cross multiplying, right? 8 times 1 and 3 times x plus 8. Either way, it's going to give us 8 is equal to 3 times x plus 8. We can then distribute the 3. We get 8 is equal to 3x plus 24. Subtract 24 from both sides. Negative 16 is equal to 3x. Divide both sides by 3. We get x is equal to negative 16 over 3. And again, we have to check our answers here. If I plug in x equals negative 16 over 3, there's only one place to test. We'll get log base 3 of 8 minus log base 3 of negative 16 over 3 plus, well, I'm going to write 8 in thirds, right? 8 is equal to 24 thirds, right? 24 over 3 is the same as 8. And then we can equals 1, and we can check, well, here on this first term, I have log base 3 of 8. I can do that, right? Nothing, we didn't actually plug anything in there. Over here, we have log base 3 of negative 16 over 3 plus 24 over 3. Well, that's the same as just 8 over 3. And I can do log base 3 of 8 over 3, right? The only thing I'm really checking for here is I cannot do log base 3 of a negative number or really log base or log base 3 of 0. Neither of those has any solution. So this case does have a solution, so we are good to go. And that was checking your answers, and we already did these.